Hey stargazers, Neil deGrasse Tyson here, your friendly neighborhood astrophysicist, ready to shed some light on a rather bright subject, the sun. Why don't scientists trust atoms? Because they make up everything. Get it? Okay, enough with the dad jokes, let's dive into the heart of our solar system. The sun, that giant ball of burning gas we all know and love, is way more than just a source of vitamin D and sunburn. It's a churning, roiling nuclear fusion reactor, pumping out more energy in a second than humanity has ever produced. Intrigued? You should be. Stick around and we'll explore the wonders of our nearest star together. First things first, let's break down the sun's structure. The sun, our very own star, is a complex and fascinating celestial body. It's not just a simple ball of fire, it's composed of several distinct layers, each playing a crucial role in its overall function. Imagine a giant onion, but instead of making you cry, it provides life-giving light and warmth. This analogy helps us understand the layered nature of the sun, with each layer contributing to the incredible energy it emits. At the sun's core, temperatures reach a mind-boggling 27 million degrees Fahrenheit. This is where nuclear fusion occurs, converting hydrogen into helium and releasing an enormous amount of energy in the process. That's hotter than a jalapeno eating contest in a sauna. The core is the powerhouse of the sun, generating the energy that eventually reaches us as sunlight. Surrounding the core is the radiative zone, where energy from the core slowly makes its way outward. This zone is incredibly dense, and photons can take thousands of years to travel through it. It's like a cosmic game of hot potato, but instead of potatoes, it's photons bouncing around. These photons are constantly absorbed and re-emitted by particles in the radiative zone, making their journey to the surface a slow and arduous one. Finally, we reach the convective zone, where hot plasma rises and cooler plasma sinks, creating giant bubbles of energy. This process is known as convection, and is similar to the way boiling water circulates in a pot. Think of it as the sun's way of stirring the pot. The convective zone is responsible for the granulated appearance of the sun's surface, with these bubbles of plasma constantly churning and moving. Above the convective zone lies the photosphere, the visible surface of the sun. This is where sunspots, cooler and darker regions, can be observed. These sunspots are caused by magnetic activity and can affect solar radiation. Beyond the photosphere is the chromosphere, a layer where solar flares and prominences occur. These dramatic eruptions can release vast amounts of energy and particles into space, sometimes impacting Earth. Finally, we have the corona, the sun's outermost layer, which is visible during a solar eclipse. The corona is incredibly hot, even hotter than the surface, and extends millions of miles into space, creating the solar wind that influences our entire solar system. The sun's anatomy is a marvel of nature, with each layer playing a vital role in sustaining life on Earth. From the core to the corona, the sun's complex structure ensures that we receive the light and warmth necessary for our existence. Now let's talk about the sun's secret sauce, nuclear fusion. This is the process that powers our sun and, by extension, gives life to our entire solar system. Without it, the sun would be just another cold, dark rock floating in space. Deep inside the core, under immense pressure and heat, hydrogen atoms are forced to get up close and personal. Like, really close. Imagine the most intense pressure cooker you can think of, but on a cosmic scale. The temperatures soar to millions of degrees, creating an environment so extreme that atoms can't help but collide. So close, they fuse together, forming helium and releasing a tremendous amount of energy. This energy is what we see as sunlight, and it travels across the vast expanse of space to reach us here on Earth. It's a journey that takes about 8 minutes and 20 seconds, but the energy itself was created millions of years ago in the sun's core. It's like a cosmic mosh pit, but instead of sweaty bodies, it's atomic nuclei colliding at unimaginable speeds. These collisions are so powerful that they overcome the natural repulsion between positively charged protons. It's a dance of destruction and creation, happening millions of times every second. This fusion process is what keeps the sun shining and provides the energy that sustains life on Earth. Every ray of sunlight, every warm day, and every breath we take is a testament to the power of nuclear fusion. It's a reminder of the incredible forces at work in the universe, forces that we are only beginning to understand. It's the ultimate cosmic power plant, running on a fuel source that's practically limitless. The sun has enough hydrogen to keep burning for another 5 billion years. That's a lot of time to keep our planet warm and our ecosystems thriving. It's a comforting thought knowing that our primary energy source is so reliable. Now if only we could harness that power here on Earth. We'd never have to worry about the electric bill again. Scientists are working on it though. Fusion reactors are being developed that could one day provide us with a nearly limitless supply of clean energy. Imagine a world where our energy needs are met by the same process that powers the sun. It's a future worth striving for, and one that could change the course of human history. Once the energy is generated in the core, it begins an extraordinary journey that spans millions of years. This energy born from nuclear fusion is the very lifeblood of our sun, and it starts its voyage in the core, where temperatures soar to about 15 million degrees Celsius. Here, hydrogen atoms fuse to form helium, releasing an immense amount of energy in the process. After its creation, the energy embarks on an epic journey outward. Remember that game of hot potato in the radiative zone? This zone is a dense region where energy is transferred through radiation. Photons or light particles are absorbed and re-emitted countless times, making their way slowly outward. Well, it takes hundreds of thousands of years for energy to escape this zone. Talk about a long game. The photons can travel only a short distance before being absorbed and re-emitted by the surrounding particles, making this process incredibly slow and arduous. Eventually the energy reaches the convective zone, where the process changes dramatically. Here, the energy is carried to the surface by giant plumes of plasma. These plumes act like massive conveyor belts, transporting the energy through convection currents. The convective zone is much cooler than the radiative zone, but it's still scorching hot, with temperatures ranging from 2 million to 5 million degrees Celsius. These giant plumes of plasma rise and fall, creating a dynamic and turbulent environment. From there, the energy bursts forth as light and heat, illuminating and warming our solar system. This energy is what makes life on Earth possible, providing the warmth and light necessary for our survival. The energy that started its journey in the core millions of years ago finally reaches the surface and radiates out into space. It travels across the vast expanse of our solar system, reaching planets, moons, and even the distant edges of the heliosphere. It's a journey that takes millions of years to complete, and it's happening right now, as we speak. Pretty amazing, right? This incredible process is a testament to the power and complexity of our sun. The energy that illuminates our world has traveled an unimaginable distance and undergone countless transformations. It's a reminder of the intricate and interconnected nature of our universe. If you're enjoying this cosmic deep dive, there's so much more to explore. The sun is just one of countless stars in our galaxy, each with its own unique story and journey. By understanding the sun, we gain insights into the broader workings of the cosmos. Give this video a like. It helps others find our channel and join in on the fun. And if you're curious about more solar phenomena, stay tuned for our next video where we'll dive even deeper into the mysteries of our sun and beyond. Section 5. Sunshine's Superpowers, Earthly Effects. Now let's talk about how the sun affects our humble little planet. We all know that the sun provides light and warmth, but its influence goes far beyond that. The sun's energy drives our weather patterns, creates auroras, and even influences our moods. It's the ultimate influencer. But the sun's not all sunshine and rainbows. It also emits harmful radiation that can be dangerous to life. Thankfully, Earth's atmosphere acts like a giant sunscreen, protecting us from the worst of it. So, next time you're lathering up with SPF, remember to thank the Earth's atmosphere too. Section 6. Fun facts about our favorite star. Ready for some fun facts about our favorite star? The sun is about 4.6 billion years old, which makes it roughly middle-aged in star years. It's also about 109 times wider than Earth. That's one massive ball of gas. And here's a mind-blowing fact. The sun accounts for 99.86% of the total mass of our solar system. That means everything else, including all the planets, moons, asteroids, and comets, makes up a measly 0.14%. Talk about feeling insignificant. Section 7. The sun's magnetic personality. Now let's talk about the sun's magnetic field. Just like Earth, the sun has a magnetic field, but it's much more complex and powerful. The sun's magnetic field lines get all tangled up due to the sun's rotation and the movement of plasma within it. These tangled magnetic fields can lead to some pretty spectacular events like sunspots, solar flares, and coronal mass ejections. Stay tuned because we're about to dive into those next. And hey, if you're enjoying this cosmic journey, be sure to subscribe to our channel and share this video with your fellow space enthusiasts. Section 8. Solar flares and coronal mass ejections. Solar flares are sudden bursts of energy released from the sun's surface, like giant solar hiccups. These flares can disrupt radio communications and even damage satellites. Coronal mass ejections, or CMEs, are even more intense. They're like giant solar burps, spewing out massive clouds of plasma into space. If a CME were to hit Earth directly, it could cause widespread power outages and disrupt our technological infrastructure. It's a good thing these events are relatively rare. Section 9. Studying the sun, a hot topic. Scientists are constantly studying the sun to better understand its behavior and how it affects us here on Earth. They use telescopes, satellites, and even spacecraft to observe the sun in different wavelengths of light, revealing its hidden secrets. Studying the sun helps us predict space weather, which is crucial for protecting our astronauts and satellites. It also gives us insights into the workings of other stars in the universe. Section 10. The sun's future. A burning question. Like all stars, the sun has a limited lifespan. Don't worry though, it's not going out anytime soon. It has enough fuel to keep burning for another 5 billion years or so. Eventually, the sun will run out of hydrogen fuel and start to expand, becoming a red giant star. It will engulf Mercury, Venus, and possibly even Earth. But hey, that's billions of years from now, so no need to panic just yet. Section 11. Keep your eyes on the skies. So, there you have it, a whirlwind tour of our amazing sun. It's a fascinating object that continues to amaze and intrigue us. Remember, the next time you feel the warmth of the sun on your skin, take a moment to appreciate the incredible forces at play that make life on Earth possible. And that's our show for today. Keep looking up at the stars, and never stop asking questions about the universe around us. This is Neil deGrasse Tyson, signing off.